Hello students, today we are going to start our new exercise 3.5 of chapter 3, playing with numbers. So in the first question we have to find the true statement and the false statements. So in the first statement it is given, if a number is divisible by 3, it must be divisible by 9. Is it true? Because 3 is divisible by 3. Is 3 divisible by 9? Obviously not. So the statement that if a number is divisible by 3, it must be divisible by 9 is false. In the second question it is given, if a number is divisible by 9, then it must be divisible by 3. Definitely the smallest factor of 9 is 1, and after that 9. 9 is divisible by 3. So all the numbers which are divisible by 9 must be divisible by 3. Okay, and also there is one more logic behind this, that 3 is a factor of 9. Okay, as 3 is a factor of 9, so all the numbers which are divisible by 9 must be divisible by 3. Okay, so the statement that if a number is divisible by 9, it must be divisible by 3 is true. Statement C, number 3, a number is divisible by 18 if it is divisible by both 3 and 6. Okay, so both 3 and 6. In my last video I have shown you that if we get co-prime numbers, then the first common multiple of those two numbers will be their product. Okay, here 3 cross 6 is 18, but 3 and 6 are not co-primes. Okay, so a number is divisible by 18 and it is divisible by both 3 and 6. 6 is such a number which is divisible by both 3 and 6, but 6 is not divisible by 18. So the statement that a number is divisible by 18 if it is divisible by both 3 and 6 is false. Okay. Next statement, if a number is divisible by 9 and 10 both, it must be divisible by 90. Now see, 9 and 10 both are consecutive numbers, and I have already told that consecutive numbers are co-prime numbers. So their product will be their first common multiple, and 9 and 10 here consecutive numbers, their product is 90. So the number which is divisible by both 9 and 10 will also be divisible by their common multiple 90. Okay, so the statement is true. Next, if two numbers are co-primes, at least one of them must be prime. Is it true? If we take 24 and 25, these two are co-prime numbers. Why? Because they are consecutive numbers. Okay, and I have told that consecutive numbers are co-prime numbers, but 24 is a composite number, 25 is also a composite number. That's why we can't say that if two numbers are co-primes, at least one of them must be prime. These two numbers are co-prime numbers, but both of them are composite numbers, so this statement is false. Okay, let's proceed. In question number 2 it is given 2 factor trees for 60. Okay, in the first question 6 and 10, these are the two factors of 60. Then 6 can be broken as 2 into 3. So one factor is 2 given, so the other factor will be 3. Okay, in case of 10, 10 can be written as 5 into 2. So one factor 5 is given, so in the gap 2 will be placed. In the next question 60 can be divided into 30 into 2. 30 is a factor of 60, 2 is another factor of 60. So 30 is given already, so in the next gap it will be placed by 2. Next 30 can be written in the form of 10 into 3. Both of them are factors of 30. So 10 is given already, so next will be 3. And 10 can be written as 5 into 2 because both 5 and 2 are the factors of 10. Okay, so let's proceed. So in question number 3 it is given which factors are not included in the prime factorization of a composite number. Suppose 8 is a composite number. If we want to factorize it in prime factorization method, the first prime factor of it which we will take to prime factorize it will be 2, 4, then 2 again, then 2. Okay, so we are not taking the two factors which are compulsory in each and every number, that is 1 and the number itself. Okay, so whenever we are doing the prime factorization of a composite number, we are not writing their factors 1 and the number. Okay, so let's proceed. In the next question it is given, write the greatest 4-digit number and express it in terms of prime factors. Greatest 4-digit number is 9999. Okay, so we have already known all the rules of divisibility. So the first prime factor by which it will be divided is 3. We have added all this and the sum is divisible by 3. So the number will be divisible by 3. So it will come 3333. Then again it will be divided by 3. Then it will come this. Then it will be divided by 11. Then it will come 101. Okay, this is a prime number. Now it can be divisible by anything. So this is the prime factorization of the greatest 4-digit number 9999. So it can be written in this way. All these factors means 3 into 3 into 11 into 101. Okay, so this will be the representation of the greatest 4-digit number. Okay, and these are all the prime factors of this number. So let's proceed. Now in question number 5 it is given, write the smallest 5-digit number and express it in the form of its prime factors. So what is the smallest 5-digit number? 10,000. So it will be factorized. So first number by which it will be divided is 2, because this is an even number. So 5,000 will come. Then again it will be divided by 2. Then again by 2. Then again by 2. Then 625 has come. So we will divide it by 5. So then again we will divide it by 5. Then again we will divide it by 5. So this 10,000 can be written in this way: 2 into 2 into 2 into 2 into 5 into 5 into 5 into 5. Okay, so this is the way by which the smallest 5-digit number can be expressed, and this is in the form of prime factorization. Okay, so we have factorized it with the prime numbers and we have represented it as the product of those prime numbers. Okay, so let's proceed. In question number 6 it is given, find all the prime factors of 1729 and arrange them in the ascending order. So first we will try to find the prime factors of 1729. I am telling again and again, you have to know all the rules of divisibility whatever I have showed in my last video. Okay, so we will divide this number by 13. Similarly, using divisibility rule, we have found it that this number will be divisible by 13. Okay, so then again we will find that this number will be divisible by 7. Okay, 19. Okay, now I have done it in this way. You can also do this in this way. You are taking the number 7 first for dividing this. Then you will take the number 13 and you will get 19. Okay, it will be better if you write all the prime factors in the ascending order. Ascending order means first number by which we will divide the number given will be the smallest prime factor of that. Then greater than the previous one, then again greater than the previous one. Means 7, 13, 19. In this way we are writing all the prime factors in ascending order. So it will be preferable if you do the prime factorization in this way. Okay. So here in this question given, so 7, 13 and 19, these are the prime factors of 17, 29. Now in the question it is given, state the relation if any between two consecutive numbers. Okay. Now 7, 13, 19. These are the prime factors of 17, 29. Okay. Now can you see that the difference between these two numbers is 6 and the difference between these two numbers is 6. So this can be one relation among them, isn't it? So the difference between these two consecutive number is 6 and these two number is 6 again. Okay. So this can be one relation between them. Okay. So let's proceed. So in question number 7 it is given the product of three consecutive numbers is always divisible by 6. Verify this statement with the help of some examples. Suppose we are taking the consecutive numbers 2, 3, 4. Okay. We have to find whether this product is divisible by 6 or not. Okay. So let's divide it by 6. 24 divided by 6. Yes, it is exactly divisible by 6. Next, we are taking the example 12, 13, 14 divided by 6. Now here 12 is divisible by 6. So we are getting the result that the number means three consecutive numbers must be divisible by 6 always. So I have taken two examples. If you can take more than two examples for your confirmation. Okay. So today up to this class, in my next video I will do the sums from 8 to 12. Okay. So keep practicing, and if any problem arises then don't forget to tell me your problems, and whatever the sums I have given already related to the last exercises, please do those sums and reply me in my comment section. So stay safe. Bye.